Hello, welcome to Code Design. In this session, we'll be solving valid parentheses, Leetcode 20. So let's go and see the problem. So this is a string problem. Given a string with containing these opening and closing parentheses, determine if the input string is valid. And what are the options? The options are open brackets must be closed by same type of bracket. So if we have a first bracket like this, it should be closing like this. If we have a second bracket like this, it should have a closing parenthesis like this, and same as third bracket. Now, is the same thing. Open brackets must be closed in correct order, and every closed bracket has a corresponding opening bracket for the same type. So let's see the input, what kind of input or example we have. Um, so this one, right? There is just only opening bracket and it is having a closing bracket. So this is good. For the next one, opening, closing, opening, closing, opening, closing. So it is a valid string. Now this one, this has a opening bracket and a different type of closing bracket. So this is false. And for the last one, we have a opening bracket here. We have a closing bracket, and we also have opening and closing bracket. So this is good. So this is our sample input, and our string length will have 10,000 at best, 10,000 characters in the string brackets, and S consists of parentheses only. So at best 10,000. So if we want to think how we will solve it, let's see what common criteria we have. So when there is a bracket, opening bracket like this, there is no action. Opening bracket like this, there is no action. Again a bracket like this, no action. When there is action, we have a closing bracket. So when we get first closing bracket, then we need to check what was our last opening bracket. So our first opening bracket was this, first bracket, second opening bracket was this, and the last opening bracket was this. So let's organize them. So this was our first opening bracket, this was our second opening bracket, and this was our third opening bracket. And when we get a third bracket here, we want to see if there is a matching opening bracket for this, and which would be the last element. So if you see this is basically a stack, right? Last in, first out. So here we input this one first, then this one, and then this one. And when we'll pop from the stack, then this one will come first, then this one, then this one. So when we have a closing bracket like this, we will look in the we'll pop from stack, and if stack is not empty and we have the matching opening bracket, then this is good. We'll go for the next input. So if our next input is this, a second bracket, then um, since we already popped it while verifying this one, so we'll get this one is already popped. So we can delete this one and we'll get this one on this stack. So we'll pop this one from the stack and it matches. So this one was deleted. And when we get this one, we'll pop from the stack. When we pop from the stack, we'll find there is a match. So this is good. We will delete this and it was popped. Now, if there is one more input, if we move forward with the next character and so this will also be deleted because it was popped. If we next we get this one, you can see that in our stack we have only one bracket which is opening bracket and matching with this. So we can pop this one. That means we can delete this from here and from this stack of this one, and we can match if it is matching with this closing bracket. So it is matching. There was same opening bracket for this, and this string is a valid string. So when the string wouldn't be valid, so same example, if we go there and see, and what if we get this one, then in our stack we'll have this first bracket, second bracket, third bracket, these three, because there is no action when we get the opening bracket. We just keep in store it in the stack. But when first time we get a closing bracket, there is action. So we need to pop this stack, and from this, when you pop from this stack, we get this bracket. So which is of course different type. So the order is not maintained here. There is opening closing bracket, but the order is not maintained here. So this is invalid. And another use case we can think here, say this match, but there is no more character. That means these two matches, but still in stack will have this opening bracket. So the condition is after the every operation, every close bracket has a corresponding opening bracket at the same time. So that means there is no closing bracket for this one. So that would be false. So let's start our code. So in Java, we have a stack class, but there is also DQ class, which is more efficient than stack implementation in Java. And we'll keep character. We call it a stack. So, and we create new array DQ object. So array DQ, we can use both stack and queue. In this case, we'll be using as stack. And what we could do here, we could actually validate length, right? Length is, let's see what's the constant for length. Length is 1 to 10,000. So what if we have been provided a string with uh, length 1, if s dot length equals 1, then we'll return false because there will be only one opening bracket or closing bracket, so it doesn't satisfy the condition. We'll return false immediately for that. And then here we create the stack object, which is a ArrayDeque, and then let's look through our characters. S dot to character array. Okay, so um, then what we can check? We can check if our C character equals first bracket or C equals second bracket or C equals third bracket. All of them are opening bracket, right? So what I said, if we have opening brackets, then what we do, we push it in the stack dot, because there is no action, but we need to store them in the stack like this. So stack dot push C. If not, if they are not opening bracket, that means they are closing bracket. So when we get a closing bracket, what we need to do? We need to pop from the stack, right? Pop from the stack and then check if they matches. But before we pop, what if the stack is empty? So there will be use cases where stack is empty. Like if we have use case like this, then first we get a we'll get a closing bracket, but there is nothing in the stack. So we need to of course check for if stack is empty. Otherwise we'll get error. So if stack dot is empty, then return false. Okay. Now we can in stack equals stack dot pop. We pop from the stack and we check if C equals this closing bracket and in stack not equals the same opening bracket. Then we'll return false. So we copy this thing, paste it here, paste it here, and then now we change the bracket. So if second bracket, closing bracket, and if we don't have a opening bracket, then return false. And the last one, third bracket, not opening bracket, then return false. So we pop from the stack and check if we have a matching opening bracket for the closing bracket we get in the character in the loop. We are doing it finally. So there is still one more condition. So what is that condition? So stack must be empty every where it says it is empty. Okay, it says there should be opening and closing bracket matching. So that means if we have input like this and this and this, these three, you can see we can keep this bracket in the stack and we can keep this in the stack. When we get this one closing bracket, we pop it from stack. This is good, but there is no more input and loop is finished here, but we still have one bracket in the stack, so that means it is invalid. So this is a very important check. We need to say return stack dot empty. So the stack has to be empty. It has to be true. If it is not, it will be false. So I think we are good, and we can run the code. Okay. So it passed the test cases. Test case 1 and 4. It passed the simple test cases. Before we submit a final, yeah, it looks good. So let's submit it. Okay, it's submitted and it beats us 97.6% of all the submission. So, however, I had one stack implementation. It was 98%. So for the input that we have, looks like stack is was more efficient than the array blocking queue. But maybe for more larger input, it is only 10,000. What if we go hundreds of thousands of element? Maybe array blocking queue will be faster. And this one is also good, 55.546% memory. And let's check the time complexity. So time and space complexity, we are using stack. So our time complexity would be O of n. And we are using stack, and at best we will store n element in the stack. So time is on and space is also on. Okay, so let me know if you like the implementation or if you liked it.